Good morning, algebra class. Today we are going to begin Unit 2. We are going to look at equations and a lot of equations. I know in the last unit we did one-step equations with adding and subtracting and multiplying and dividing. In this unit, we're going to have longer equations, and it's really important that you write out each step. Now, I've decided to do the notes in the videos a little bit differently. I got some feedback that it was too much work. So instead of having you fill out all the notes and do that first practice, we're going to fill out the notes together. And then at the end of Ed Puzzle, I'm going to put in 5 questions. Those are going to count for your notes grade. And then instead of marking up a PDF for your first assignment, we're going to go to Delta Math because I really like that. And you can get feedback right away on Delta Math. So if you have a scrap piece of paper, try these out. Or you can still print this out. I will still put that up there for those of you that are printing it and marking up the PDF. So if that's still working for you, keep going with that. For number 1, we want to practice our order of operations and we want to simplify. Remember, your order of operations is P-E-M, D-A-S. But the M and the D happen at the same time, and so do the A and the S. So in number 1, 4 divided by 2 is the division piece. We want to do that first. So that's our 2. So we have 6 plus 2 plus 3. Then we're going to add 6 plus 2, which is 8, plus 3 gives us 11. For number 20, I see multiplication and also an exponent. We want to take care of that exponent first. So 3 squared is 9. So 20 times 2 is 40. And 40 minus 9 gives us 31. For number 3, we want to order the numbers from least to greatest. Now, I see a square root in here. I see the square root of 9. That's really 3. The square root of 5, I'm not exactly sure what that is, so I'm going to use my calculator. And I've got 2.23. 2.23. So if we go from least to greatest, your negative numbers, negative 7 over 2 is really negative 3.5. So negative 7 over 2, got it. Negative 2.1, got it. That square root of 5 is next because it's 2.23. The square root of 9 is after that, and then 3.5. There we are in order from least to greatest. And to solve the one-step equations, I was getting a lot of work from you guys that just had the answers. And I know you know the answers for some of these, but it's really important to write out your steps. So we're going to divide each side by 3. Negative 9 divided by 3 is negative 3. For number 5, we're going to subtract 10 on both sides. 8 minus 10 is a negative 2. For number 6, we're going to divide both sides by 1/2. So x is equal to 20. And for number 7, I divide by negative 3/4. And if I use my calculator is going to tell me that is negative 12. All right, there we go. Some warm-up problems. Those were all topics from Unit 1. Now, identifying parts of an algebraic expression. They didn't put one in here for us, so I'd like to write an algebraic expression. I'm just going to make one up. I've got 4x squared minus 6x plus 7. I just made up an algebraic expression. The terms, each of these are the terms. The terms are separated by addition and subtraction signs. Your like terms have the exact same variable and same exponent. A coefficient is the number in front of a variable. And a constant is a number that does not have a variable. So on the example that we have here, the number of terms that we actually have 3 terms in the one that I drew. Like terms, I didn't give you any like terms in this example. X squared and X are two different terms. They're not like terms. Coefficient is the number in front of a variable. So in this case, I've got a coefficient of 4 and -6. Those are my two coefficients up here. And my constant is the number without a variable, so that's a 7 on the end. So those are examples as to what's what. Now, the next page has a whole bunch of these. I'm going to do one of them together, but we're not going to do the rest. I don't think it's necessary. There are, in example A, 4 terms. The like terms that I have are the ones that are the same, so a 3x and a -6x. My coefficients are the numbers that are in front of the x's, so it's a 3 and a -6. And the constants are the numbers that don't have a variable, -4 and 2. We have a whole page of those, but I don't really want you to fill those out. Those get a little boring. Here's what I need you to do. This is the important part. I need us to be able to combine like terms. We need to be able to add and subtract and multiply when appropriate. So in example A, I have 8x squared and 2x squared. They both have the same variable with the same exponent, so we're allowed to add them. 8 plus 2 gives us 10x squared. Ta-da. In letter B, we have a y term here and a y term here. Now, what number is in front of that second y? It's a -1. So 3 minus 1 gives us 2y. And we're in good shape there. Now, in letter C, I have 7mn to the 4th and -4mn to the 4th. Those match exactly, so they are like terms. So -7 minus 4 is -11mn to the 4th. In letter D, this is where it gets a little bit more interesting here. So let's start to identify our like terms. I have a 2x squared, but no other x squared terms. Then I'm going to look for the x's. I have a 3x and a 7x. Together, those are 10x. And then I'm looking for my constants. 4 plus a -1 becomes 3. That's my final answer. You have to make sure they match exactly with those exponents. So in letter E, I have a y cubed z, and over here is a y cubed z. So this is 9y cubed z. I don't change the exponents, those stay the same. And on this one, I have a -6yz to the 6th. Great job. In letter F, we're looking for like terms. So I have 8x squared and 12x squared gives me 20x squared. I have a 3x, there's nothing else that combines with. And I have a -9xy, nothing else that combines with either. So there's our answer. In letter G, here's an x cubed. Do you see any other x cubes? Nope, so that one's by itself. I have 42x and 36x. Those are like terms, so I have to take 42 minus 36. I can use my calculator if I need help, but that will be 6x. And then I have a +8 on the end. Combining like terms. Hopefully this is a review from last year, I hope. But if not, this is good practice. All right, take a minute, try these, write them down on scrap paper, or if you printed out the notes, they're here and they're ready to go for you. So go ahead and give those a try. Okay, so I've gone through and done these already for you, so you can check your answers here. In letter A, those are both like terms, so 2 minus 9 is -7. In letter B, I add the c's, so 6c plus 2c gives us 8c. 4 minus 7 is a -3. In letter C, my m squared, that's the only term that I have that's m squared. I have a -7n and a -4n, so that's -11n. Then my -3 is all by itself, nothing to combine with. In letter D, 2n minus n is 1n. My -4m doesn't have anything to combine with, nor does the 1. So I just bring those down. Now, letter E. I left this one so that we could do this together. I'm looking at x squared y. So I want to see if I have any other terms that are exactly x squared y. That made an arrow. I didn't know that would make an arrow. So x squared y, here's an x squared y. Now the one on the end is xy squared. Close, but not the same thing. So that one doesn't count. So 3x squared y minus 2x squared y is 1x squared y. Now let's look for another one. This one's close. Xy squared, I don't have any others of those, so I'm going to say minus 2xy squared. And then I see a 2y, no other 2y, so I'm going to bring that one down. And then I see a 4x squared and a positive 3x squared. So those are like terms, I can add those. That's 7x squared. So go ahead and write that one down. That one's nice and long. So sometimes you wind up with just one term like you did here. And sometimes you wind up with more than one term. We have 4 of them over here. So this is Algebra 1 now, we're in high school, so our answers can be a little bit more complicated. At the end of this video, I have 5 multiple choice questions for you to try. It'll tell you if you're right or wrong, give those a try, and then you're going to go into Delta Math and try some examples there.